So this lecture we're going to talk about addition and subtraction of rational expressions. In the previous lecture we talked about multiplication and division, which is actually a little bit simpler because when you're multiplying fractions, say you had like a over b times c over d, right? All you have to do in this situation is just multiply the numerators and denominators, right? And if it was division, like if it was a b divided by c over d, then you just write this as a over b times the reciprocal d over c, and then you would use what we have up here, up above, to write that as a times d over b times c. Of course, you could also write this expression as a divided by b divided by c over d. And we'll use this technique in certain situations. But that was before, right? This is before. Okay, but now we're dealing with addition and subtraction. So we have to be a little bit more careful, right? So so that was multiplication and division. And now when we're doing addition and subtraction, what we actually really need is, so now addition and subtraction, if we have some general fractions, right? Let's say that we have a over b and we want to do plus or minus c over d. Before we even do this, first we must find a common denominator. Okay. One way that you could do that to find a common denominator is we could do the following. I could take a over b, and what I could do is I could make d appear in the denominator by multiplying by 1 essentially, but I'd write that as d over d, which is 1. And then I can multiply this expression by b over b, and that would give me a common denominator of this. So AD over BD plus or minus CB over BD. And then now that I have a common denominator, then you can proceed and simplify. So this would become, so once you have a common denominator, then what you do is you either add or subtract the corresponding numerators, right? And then you put that over the common denominator. Okay, so I'm writing everything in general, but the key difference is when you're adding and subtracting, you must find a common denominator, and that's not necessary when you're doing multiplication and division because you just have to multiply accordingly, right? Each of those can be translated into multiplication, and then you just multiply the numerators and denominators. But with addition and subtraction, we're going to have to do a little bit more work. We'll have to find a common denominator, and sometimes you won't just do this multiplication. You know, that's just one way to guarantee it. Another way is you might multiply by other factors and sort of find the another common denominator. But in the end, you must have a common denominator before you can actually do the operation. But if we look at our first example here, we want to add these two rational expressions together, and if you look at them, they already have a common denominator. They already have this y minus 8, right? Already have a common denominator. So we don't need to adjust either of those fractions. We can just do the operation, which is 8 minus y. And then we put that over the common denominator of y minus 8. Okay, now it looks like we're done, but if you remember from the previous sections, we can actually reduce this expression because you have 8 minus y and y minus 8. So we can actually make the numerator, we could factor out a negative. You see, if I factor out a negative, then this will become negative 8, and that'll become positive y. So negative 8 plus y over y minus 8. And the numerator, this right here, is the same as y minus 8. So y minus 8 over y minus 8. And so then these reduce, and you just get negative 1 in the end. So moving on now, let's look at our fractional expression like this. You probably already have encountered doing this type of operation before when we're talking about ordinary fractions, but just to remind you of the procedure, it's exactly what we were talking about over here. You want to find a common denominator, but the simplest one is to find what's called the least common denominator, right? So we want to look at the multiples of all these denominators, and we want to find the least common denominator. So what would that be in this case? Well, 3 and 6 are both divisors of 12. So we can actually multiply 3 by 4 to make it a 12, and we can multiply 6 by 2 to make it also a 12. So that looks like that would be our least common denominator. In other words, it's also the least common multiple amongst all of the denominators, right? So 12 is a multiple of 3, 12 is a multiple of 6, 12 is a multiple of 12. So what do we have to do? Okay, now we're going to take this 1/3, and to make a denominator of 12, we're going to multiply by 1, right? We can multiply by 1, and that's unchanged, but we're gonna multiply by 4 over 4, and that's our 1. This will give us a denominator of 12. What about the minus 5 over 6? So for this one, we want a 12, so we're going to have to multiply the 6 by 2. So I have to multiply the numerator by 2 because I'm multiplying by 1 here, right? This is 1 and this is 1. So it's perfectly legitimate to take something and multiply by 1. You're not affecting it. I'm just we're cleverly rewriting 1 in a way that's going to be useful for us. And then plus 5 over 12. Okay, so at first, when you first learn this, it's a little bit strange, but in this next step, it'll be kind of clear why did you actually do that intermediate step. Well, simplifying and now using our previous knowledge, when you multiply fractions, we're just going to multiply the numerators, which is 4, multiply the denominators, which is 12, and then we'll have minus 10 over 12, and then plus 5 over 12. Okay, and then now we have this common denominator that we were referring to up here. But this is a special one. This is the least common denominator. We can make many common denominators. For example, we could have made the denominators all 24, but the least common denominator is what's called the least common multiple, okay, amongst all of the denominators that we initially began with. So now that they're all in common, what we do now is just we do the operation. So we will do 4 minus 10 plus 5 in just the numerator, and then we will divide by that common denominator of 12. And now we just simplify, so that's 9 minus 10, which is minus 1 over 12. Moving on to some more complex rational expressions. We have x plus 7 over 2x minus 12 and 6 over x squared minus 36. Okay, now we want to find the least common denominator amongst these two, so that way we can add them. All right, now how do we do that? Well, when we're dealing with something more complicated than just fractions, like you're probably already used to, here we have rational expressions. And what we've been doing is factoring, right? And that's going to be crucial here because factor the numerator, well, it's already factored, but what about the denominator? We have this common factor of 2, and then we have x minus 6. And then over here, we can factor the denominator because this is a difference of squares, so that'll be x plus 6, x minus 6. Okay, and then now it's a little bit easier when we look at these two fractions, how we can make a common denominator, right? So what would the least common denominator be? Well, if you look at this fraction, and this fraction's denominator, what do we have? Well, here we have a factor of 2 and x minus 6. And over here we have a factor of x plus 6 and x minus 6. So already they share something, right? They share this x minus 6. Okay, so we're not going to need to add that extra factor in since it's already common between those two. But what is missing from this first one? So we have x plus 7 over 2 x minus 6. Okay, what does this denominator have that this one doesn't? Well, it has this x plus 6. So you know what? We're going to multiply by the missing factor, right? We're going to multiply by that missing x plus 6. But if I multiply the denominator by that, I also have to have that in the numerator, because I can't just multiply by something arbitrary. I can only multiply by 1 if I'm going to leave it unchanged. So you see, I'm multiplying by x plus 6 over x plus 6, because the x plus 6 is what this fraction's denominator had that this one did not. Now let's ask ourselves the same question with the other fraction. So over here we have plus 6 over x plus 6, x minus 6. And now at this point, what does this fraction have, this denominator, that this one does not have? Well, it's actually just missing this 2 here. So we're going to multiply by 2 over 2. Okay, so 2 over 2. And then now if you look at this, before we proceed, look at the factors of the denominator. We have 2 x minus 6, x plus 6, 2 x minus 6, x plus 6. So now you see that this is going to result in a common denominator. So now we can simplify a little bit, right? What do we actually have? Well, we have x plus 7, right? We should really put that in parentheses, times x plus 6. Okay, and then this is all over 2x minus 6, x plus 6, plus 12. Well, we could write it as 6 times 2, and then we'll simplify. X plus 6, x minus 6, and then we could put the 2 here if you want. Okay, now look at what we have. We have a common denominator, right? The factors are just written in a different order, but they're there, and by commutativity, that's fine. So what do we actually have here? This is x plus 7, x plus 6, and then plus 12, and then divided by this common denominator. So 2x minus 6, x plus 6. Okay, now can we do any reduction? Well, if there is reduction to be done, the only way that we could do that is we'd first have to expand the numerator to reduce, right? Be very careful. You cannot just reduce this x plus 6 and this x plus 6, because that's not a factor of this 12. Okay, so in order to reduce further, we would have to expand this. So foiling this out, we have x squared, and then plus 6x plus 7x, so plus 13x, and then plus, looks like 42, plus 12, and then don't expand the denominator. Okay, leave that alone. So do not expand the denominator. Okay, the goal at this point is to factor the numerator so we can simplify further. Right? We've already added them together to produce one fraction, but we want to simplify it. So the only way to do that is to factor the numerator. So remember these two things, right? After you do that, you're going to factor the numerator, and the only way to do that is to expand it first. Okay? I mean, unless this had some factor that you could factor out, and then maybe that would cut some time out, but that's not going to happen here. Okay, so what do we actually have? We have x squared plus 13x, and then plus 54. And you can start to think about the factors that are going to work there. Okay, well, what are the factors of 54? Well, 9 and 6, right? Anything else? Well, if we think about all the factors of 54, so we'd have 1 and 54, 2 and 27, 3 and 18, 6 and 9. I don't think any of those are going to give us the sum as 13. So what that actually means here is that this numerator is irreducible. There's no further reduction that can be done. Later on, as we progress in this course, those will be a little bit easier to identify. There's actually a quick procedure that we could do to identify that that numerator is no longer reducible. So since that's the situation, that would be the answer here. Okay. You potentially, if this does factor and there are some common factors on what's left over, you would just reduce those out. But that didn't happen in this case. So that's perfectly fine. It's just something you got to see by trying. Okay. So let's look at our next example. So we have 5 over 2x minus 1, and then we want to add 6x plus 7 over 1 minus 4x squared. So we don't have common denominators, so we can't just immediately do this addition. So let's factor as much as we can. So the denominator, we're not going to really be able to factor any more out of that. I mean, there's no common factors amongst these things other than 1. That's not going to make it any better. So 6x plus 7. And then what about this denominator here? Well, we have a difference of squares, right? This is 1 squared. And what is this expression? This is 2x squared, right? So we can write this as 1 minus 2x, 1 plus 2x. And that, do you see that they actually now do have a common factor, right? So look at what we could do. I could factor a negative out of this, which would be, so negative 2x and then plus 1, right? 6x plus 7 over 1 minus 2x, 1 plus 2x. And we could move this negative up here, but this is actually 1 minus 2x. So I could put the negative up top, or you could leave it there if you want and then try to add the negative over here, but I'm just going to make it less confusing. In my opinion, just move the negative up here. That's perfectly fine. And then we have a 1 minus 2x. The only reason I'm doing that is just so we can see that that's the only thing that's missing from over here. Okay? So it's 6x plus 7 over 1 minus 2x, 1 plus 2x. Okay, so what would the common denominator be? What's the least common denominator, right? Well, this first fraction is just missing in the denominator the 1 plus 2x. So let's make that appear. So we would do negative 5 over 1 minus 2x, and we will multiply by 1 plus 2x divided by 1 plus 2x. And then this one, 6x plus 7 over 1 minus 2x, 1 plus 2x, right? And simplifying a little bit more, so what do we have? We have negative 5 times 1 plus 2x. And now that these denominators are common, we can just add these numerators, plus 6x plus 7, and then divided by the common denominator. And how do we proceed? So at this point, we've combined them. So leave the denominator alone. Do not expand that, but we will expand the numerator. Right, so now we will expand. Sorry, that's a little bit off the screen there, but you know what? Let me just not even write it. You know, we're going to expand the numerator. So what do we get for that? So this will be negative 5, and then negative 10x, and then plus 6x plus 7 over these two factors, 1 minus 2x, 1 plus 2x. Simplifying a little bit more, so the minus 5 and the plus 7 become a 2, and then the minus 10x plus the 6x gives us a minus 4x. Minus 4x, and we'll be able to factor and reduce a little bit, it seems. Okay, so we can factor this, and that becomes 2 times 1 minus 2x over 1 minus 2x, 1 plus 2x. So that reduces those two, and we're left with 2 over 1 plus 2x. All right, so for our next example, we have this sum here. 1 divided by a plus b plus 3ab over a cubed plus b cubed. So what are we going to have to do here? Again, find a common denominator. We have the sum of two cubes, and we have a nice formula for that, so the factorization will be pretty quick. We can't factor this, but what could we do? So let's write this out. 1 over a plus b, no factoring going on there, but then we can have 3ab divided by, and then the sum of two cubes. Remember, the formula for this is a plus b, a squared minus ab, and then plus b squared. Okay, and at this point, so we have this a plus b in this first fraction. So comparing these two denominators, the only thing the first one is missing is this trinomial term. So we're going to multiply and divide by that, right? So we're going to multiply by a squared minus ab plus b squared divided by that same factor, a squared minus ab plus b squared, plus 3ab over that factored cube plus cube, and now we can add the numerators and simplify as much as we can. So what do we get? So we have a squared minus ab plus b squared, and then plus the 3ab divided by our common denominator, a plus b, a squared minus ab plus b squared. And then now what we have here is a squared. These two are common, right? They both have ab's in them. So minus ab plus 3ab gives us positive 2ab plus the b squared. That's the only other term left over. And leaving the denominator alone, there's no reason to expand the denominator at this point. But the numerator definitely factors, right? Numerator is what? That is a plus b times a plus b, right? A squared, ab to give us a 2ab, and then plus b squared divided by the a plus b over a squared minus ab plus b squared. And we reduce one of the a plus b's, and we're left with a plus b divided by this trinomial that's not going to factor. And that is our answer. Continuing on. All right, so let's see what we can do here. So we're going to add these two. So we have to find a common denominator. Let's factor as much as we can. The 2 and the 5, right? We're not going to be able to factor anything out of this. But what do we have over here? 21 over, and what is the factorization here? Well, using sort of a process of trial and error, right? We can try to make the 8t squared and the final product of negative 15. Luckily, negative 15 doesn't have very many multiplicative possibilities, right? The factors of that are 5 and 3. And since we're getting a negative and a negative, probably the minus 5 and the plus 3 would be good choices. And then now we could try to make this work with the 8t squared. So if we want a minus 14t, this is sort of, again, by trial and error, right? If this is wrong, then we would pick some other factors of 8 to make this work out. So what does this work? So 8t squared, and then we'd get 6t, and then minus 20t, so that will give us the minus 14t, and then that's negative 15. So that is the correct factorization. And look, we actually do have something in common. So the only part of the denominator over here that we're missing is this 4t plus 3. So we're going to take this fraction, and we are going to multiply and divide by the missing 4t plus 3 over 4t plus 3. This is a 4, not a 9. Plus this. And what do we have here? So now this is 3 times 4t plus 3 plus 21 divided by the factored denominator. And then we get 12t plus 9 plus 21 over 2t minus 5 4t plus 3. So we get 12t plus 30. And is that going to help us? Well, what can we factor out of this? We can factor out a 6. Let's see if that helps. So 6 will be 2t plus 5. Well, if that was a minus, that would have been nice. But since it's not, we're not going to be able to reduce anymore, so this is the answer. Right? If that were a minus, we could have reduced, but it didn't happen, so this is the answer. So let's take a look at the next example. So now we have 5, right? So 5 plus this fraction. Well, 5 is missing this 4 minus t in the denominator. So how can we make that appear? So we can take our 5 and we can multiply by 4 minus t over 4 minus t. And then we'll just leave this one alone, the 4 minus t. And then we have 5 times 4 minus t plus 2 over 4 minus t. Okay? If you're just given a constant like this, you can make the denominator appear, right? Just like we were doing before. We were making the missing factors appear, but you can turn it into a fraction by, multiplying by 1 in a clever way. And that was the clever way. So we have 20, right, distributing the 5 now, minus 5t plus 2 over 4 minus t. So this will be 22 minus 5t over 4 minus t. No common factor amongst those two, so no reduction, it looks like, and that will be our answer. Continuing on to our next example. All right, now we have 3 fractions, right? So we're going to add these two and then subtract this one. So since we're dealing with 3 separated fractions, we are just going to use the same exact procedure. We're going to try to find a common denominator. So let's factor each one as much as possible. First one looks like it's already factored as much as we can factor it as, but here we have a common factor of 3, so we have x plus 3. And then over here we can factor what? Well, we have x squared plus 3x. So we have a common factor of x, and then we have x plus 3. Okay, so what's missing? So we have a denominator of x plus 3, 3 times x plus 3, and then x times x plus 3. So if we want to give us the sort of least common denominator, right, what are we going to need? Well, this fraction is missing a 3, and it's also missing an x. Okay, so we're going to take this first fraction, and we're going to multiply and divide by those missing factors, right? So it's missing. We have the x plus 3, but what are we missing? We're missing a 3, and we're missing this x. Okay, so we're going to multiply it and divide by 3x. What about the second one? So we have 7 over 3, x plus 3. So now this has the 3 and the x plus 3, but we're missing the x that we need from this one. So we're going to multiply and divide by x. And then the last one, we have minus 2 over x plus 3. So we have the x and the x plus 3, but we're missing the 3 that we had. So we're going to multiply and divide by 3. Okay, so that's the procedure. Look at all the denominators involved and just ask yourself, what is this missing? Well, comparing it to the second one, it's only missing a 3. Comparing it to this one, it's only missing the x. So that gives us the 3x. Okay, and then once you have this, that's the denominator we're aiming for all of them, right? So then you look at this one, it's going to be missing something potentially, and you add that in, and right? So it's pretty systematic. But once everything is factored, it's actually a little bit easier to see what's missing, right? So now simplify. So we have 3x squared. We have the common denominator. So at this point we can we can deal with the numerator. So we have 3x squared plus 7x, and then minus 6 divided by the common denominator, right? The denominator is the same for all these, so that's the x plus 3 times the 3x. You know what? I'm going to put the 3x out here. That's sort of standard to put the constant first, and then maybe if you have x factors, put those by themselves. Okay, and now we just have to factor, right? Now, since it's the 3x squared, the only things that we can have are 3 and x, and we need a product of -6. So one of those is going to be positive, one of those is going to be negative, and it's sort of a trial and error situation that we're used to, right? So we could do 1 and 6, we could do 2 and 3. Okay, if we did 2 and 3, if I make the 3 and 9 and then a -2, I could get a +7. So what if I do +3 minus 2? Okay, let's see if that works. I don't know. This is trial and error, right? You have to try it and then see if there's an error. Okay, so 3x times x gives us 3x squared. Then we'll have a 9x minus 2x, so that gives us positive 7x. And this multiplication, the last one, will give us the -6. So that looks correct. Divided by 3x times x plus 3. And now, at this point, do we have any reduction? Yes, we do. And then we're left with 3x minus 2 over 3x. Okay? And this is sufficient answer here. Okay? You actually could expand this a little bit. This is actually the same as 1 minus 2 over 3x, but this is perfectly fine. Don't overcomplicate it if you don't need to. This is perfectly fine as is. Okay?